plus 7b equals 7. I deliberately put a gap underneath the c.
Would it not be -7?
I added these two to the other side,
Right.
and then just flip the equation around.
Oh, I see it now.
And then the last one becomes 7b minus 6c equals -2. Now the gaps are there. I do have a gap in the second equation for the c term. And so recognize it's just, there's no c there, so it's plus 0c. And for the first equation, I have no d term, so it's plus, so I have a 0d there, plus. The zeros matter when we set up Kramer's rule. Now, I'm now going to do 3 fractions. Like first, I'm going to solve for d. The denominator is just the coefficients, is the determinant of the coefficients of what I have over here. So my determinant of 1, -1, -1, 3, 7, 0, 0, 7, -6. So I'm just going to do find the determinant of this 3 by 3. The denominator for each of the fractions is the same, so once we do 1, we got the other 2. The numerator, recognize we haven't brought in the right-hand side yet. We have to do that at some point, and now's the time. Since d is the first variable here, I have them all lined up there. I'm going to replace d with the coefficients of d with my numbers there. So I have 0, 7, -2. And the other 2 columns are the same. -1, 7, 7, -1, 0, 6.
Could you explain that one more time? Oh, wait, I'm sorry. I got it.
Okay.
Unless someone else wants to hear it.
And clearly, looking at those determinants, the answer is 1.295. Let's actually solve it. So the denominator, I'm just going to repeat the first 2 columns, -1, 7, 7, and then multiply those together. 1 times 7 times -6 is -42. 1 times 0 is 0. -1 times 3 times 7 is -21. Minus, go the other way, I have 0, 0, and 18. -63 minus 18 is -81. Unless there's a mistake there. Westlight. I know it keeps slipping off, but
Oh, mine.
oh, okay, thank you. Questions, any corrections or questions about the -81? Now remember, when we solved one of them over there, we had a denominator of 8.1. So I'm feeling like we're on the right track here. Up here, 0, 7, -2, -1, 7, 7. And so I got 0, 0, -49, minus 14 plus 0 minus 42. So that's negative 49 minus 28, which is negative 77. Something's off. Put something down, so we got, so that comes over, that's negative 2. Then I had 3 plus 3d, 7d, 7, good with that. And then d minus b minus c, okay. 1, negative 1, negative 1, 3, 7, 0, 0, 7, negative 6. Then I replace the first column. Ooh, that's negative 6 right there. And just demonstrating how easy it is to lose a minus sign. So that doesn't change that 0, but it does change that to 42. So negative 49 minus 56, which is 1 and 5, negative 1 and 5. And so D is equal to negative 105 divided by negative 81, which I just got the thumbs up over there, so I assume we actually got 1.295, and then enter.
296, but yeah.
296, okay.
20 plus 9.
However, I'm feeling pretty good that we did something right. It's close. Anna, you have a look on your face that says you have a question.
Yeah, I'm not getting the negative 42 piece. I mean, positive 42.
Do you have the negative 6 here? That was, I made a mistake.
Yes, that's the problem. Thank
Yeah.
you. Got it.
Now, if we hadn't done the problem already and I had an answer over there, I would not have suspected there was a mistake there until later. Which is why it's, 90% of a class getting the problem completely right is incredibly unusual, because it doesn't take much to mess up. All right, so we have D now. Let's solve for B. And take some room over here. Well, I know my denominator is negative 81. My numerator, since B is the second variable listed, and it is based upon the order in which I write them down here. B is the second one, that's the one I'm going to replace, so I've got 1, 3, 0, that's my first column. Second column is going to become 0, 7, negative 2, and the third column will be negative 1, 0, negative 6.
I feel like the math people just have a little bit too much time.
Yeah, I agree.
Like, this is ridiculous. It's like, it feels like a game.
Yeah, it really is.
The
Very hard game.
Yeah. I was curious about the proof of this one, and some students happened to be taking linear algebra at the time, and someone brought in the textbook. It's a 2-page proof. It required, as with a lot of things, there's conservation of complexity. The shorter the equation, the more stuff that gets packed into every single letter. All right, so solving the first one, I have 1 times 7 times 6, negative 6, so I got negative 42, plus 0, because 0 times 0 times 0, and then 3 times negative 2 times negative 1, which is 6, minus 0 plus 0 plus 0. zeros do make our life a little bit better here. And so we end up with negative, if I can do math, negative 36 over negative 81. Which is 0.4 repeating. Amperes. Now, I'm going to go through Kramer's rule for the third one. Realistically, I don't have to use Kramer's rule because I have a really simple equation right there, which tells me that D equals B plus C. I think I could figure out C from that, but let's do Kramer's rule, sticking to the purity of the method. And so C is equal to, well, my denominator, negative 81, I got that far. So now I got 1, 3, 0, negative 1, 7, 7, and then I'm replacing the third row, or third column, 0, 7, negative 2. Negative 14 plus 0 plus 0 minus 0 plus 49 plus 6. Negative 14 minus 55, negative 69 over negative 81. I think last time we did it, we had 6.9 over 8.1. Say 5.1. Questions? All right, so this is relatively new. Wesley's already declared that he does not plan to use this. That's
I'll
what-
watch this video again and try, but I just don't see myself doing it.
If you go under coursework for chapter 21, I go through the two math techniques that we did here in more detail. So I mean, I think that's a pen and paper video, and I do solving simultaneously also. It depends upon the math technique that you like. There's a fourth technique that I don't do, and that's called use your calculator. Some of your calculators, the TI 80 whatevers, do it. My HP does it. There are other calculators that do it. If it can handle matrices, it probably can solve the system of equations. The plus side to it is it saves a whole lot of headache if you can do it, if you know how to use your calculator to do it. The downside is I can't see any of the work. It's, you get the equations and then you make some note of, I use my calculator, and then you give me an answer. And if you are wrong, if you mistype something, I mean, assuming based on these equations, if you get some answer that's not correct given the equations that you wrote down, there's not a lot of partial credit I can give you in the math section of it.
So you can probably check yourself, but
And so,
probably wouldn't do.
yeah, so that is the downside if you want to use your calculator for it. All right, so I'm about to go through mesh analysis, method 2, to get the equations, and then the math piece is, oh, one thing I haven't done. Let's talk about, so it's not a surprise to you, the way the question is actually asked on the test and the chapter 21 quiz. No, actually, I don't think I do it this way on the quiz, but on the test. I set it up. The question is, what's the current going through each resistor? And what's the voltage across, we'll just say the 6 ohm for now. You will then see a table that's like R1, R2, R3, R7, R8, and delta V. I think I said 6. Oh, that should be a 6 there. Let's do that in order, 6 and 8. Kind of how I have this row labeled. I think I have value, something like that, and then direction. Now, I don't have units under the value column because I have voltage down there in addition to what we're trying to find is actually current. So this would be, if I'm looking at the 1 ohm resistor, I predicted my current was going to the right, and I got a value of 1.295 amperes, so I put 1.295 amperes to the right. The resistor number 2 down there, I predicted it was going to go to the left, and so I had 1.295 amperes left. My 6 I predicted to the right, and I got a positive number, so that was C, so 0.85 amperes to the right. And for some reason, I keep wanting to write an 8 there. And then my 7 ohm resistor is in the middle, and I said it was going down, current was going down, and I had a value of 0.4 or 0.44 repeating amperes down. Now, I was kind of hoping we'd get one of them as negative, but let me talk about if we'd gotten it negative. If we had predicted C goes the other direction. So very first off, we defined C to be going that way, counterclockwise. We would have had a value of C is equal to negative 0.85 amperes. So if we had picked C in the other direction, that's what we would have gotten. When it comes time to actually writing down the answer, the 2 ways you can write it that are perfectly acceptable. You can write it as 0.85 amperes going to the right. Because if I had predicted going into the left and I'd gotten a negative, that means, oh, it's the other way. Or I could have written it as negative 0.85 amperes to the right. I'm sorry, to the left. Both of them are perfectly correct answers. What some students have done is they recognize they got the minus sign and said, oh, it's the other direction. And then they basically changed the way that they defined it initially. And they put down the positive number. No, see. They kept the negative and they switched the direction on the drawing, which suddenly made it wrong. So if you're going to change it, change both. Don't change just one of them. All right. Now I've had students get this far into the problem, and suddenly they mess up here with the direction. So first off, what is the magnitude of the potential difference across the 6 ohm resistor? How would you find the voltage across the 6 ohm resistor?
Formula, was it a formula?
Yeah, what formula?
Is it Kirchhoff's? No, what is it?
You just take the current flowing through and multiply it by the number of ohms that the resistor is, right?
Yes, Ohm's law is what you're.
Yeah, Ohm's law, I was thinking of. I can't remember.
All right, so delta V is equal to IR. And so 6 times 0.85 which is 5.1. So right now, 5.1 volts. In which direction? First off, hint, it's left or right.
It's the opposite direction of the current, isn't it?
It's 5.1 volts if I'm going against the current. It's negative 5.1 if I'm going with the current. So we can write down 5.1 volts to the left or negative 5.1 volts in the same direction as the current to the right. Yeah, there was one particular class that, there were several of them who got really close to getting the correct answer and then messed up that on that.
You can see why.
Now, part of it is test brain. You get in there, you're in panic mode, or you're at the end and you're thinking, I just want to be done with this.
Side note, is anyone familiar with Nausicaa, the Valley of the Wind? The Ohms. It's a Miyazaki movie. Spirited Away. You know Miyazaki? Okay, never mind. There are ohms. They're very significant. Never mind. It's fine. Let's continue.
What was the name of it?
The film is called Nausicaa of the Valley of the Wind. It's from like the 80s or 90s. It's an older Miyazaki film, but it's really, really good.
Is it Muse docufilm?
Hayao Miyazaki.
Oh, Miyazaki film.
He's more well known now. Huh?
Studio Ghibli.
Yeah.
What'd you say?
Studio Ghibli. Japanese Disney.
Yeah. Da, 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 da. Never mind. Let's move on, please.
I feeling it.
I'm done.
You're just nerding out.
Yeah.
Hey,
It's fine.
hey, this is the place to do it.
The ohms are great. They're enormous. If you ever see it, you'll know.
All right, mesh analysis. Some people find mesh analysis easier. You know, ultimately, it's how's your brain working on the day you need to do it.